Hi everyone, I hope you can hear me. If you can put your headphones on and give me a wave if you can hear me. I didn't think it'd be that quite busy this afternoon, so thanks for all your guys attending. So my name's Dean Hutchinson. I'm a field applications engineer at Würth Elektronik. I've seen a couple of your guys knocking around the store this morning, so thank you for that. So I'm a field application engineer specializing in IoT. My background's 30 years as a hardware designer, and when I initially left school, I was a TV engineer. So when I started life, I was working on thermionic valves in TV sets, and now we're seeing the explosion in the IoT. So you can imagine the changes and the difficulties as an older person coming to IoT sensors and getting something to work. So what this presentation's about is simplifying how to create an IoT device. Is it scary? What can we do to simplify it? So a little bit of a background on IoT devices. So what's as agenda today is basically what's growing the IoT market, the tools that we need to create one. I mentioned here a FOSI, we'll come on to that later on, the compilers that we might want to use. How do we add a sensor to this? How do we create an actual IoT device? And basically, how can we get this information onto the cloud? So we're not going to go into a really in-depth on how to do the security side of it, because we've had a lot of speeches earlier on today that cover all that information, and we can go into that in a bit more detail. But seeing as we've only got 30 minutes, it's a really simplified approach here, as showing what products we can offer, how you can do this. Quite a few of you might have come across MQTT and Node-RED and everything else, and that's a really powerful tool. And we'll go into how simple it is to publish those commands. So what's driving IoT? A lot of it is basically sustainability. How can we lower its energy use, monitor a process, get that information back up, monitor it. So any IoT is only there to get a sensor value back to the cloud for something to make a decision about it. This chart, what I've got on behind me, is quite interesting. It was published in 2023, and it projected that there'll be 30 billion IoT devices by this time in the next few years. However, when I went on to Chatbot GPT, it already predicts that this model is well out of date. It's nearly double that. So we're up to nearly 70 billion devices connected. And what's interesting, that most of the IoT markets split into Bluetooth and Wi-Fi. And the subsection of that will be Zigbee and other protocols like that. The cellular's making up, but this doesn't include any computers, tablets. It's only the end device. So the little, they class as end devices, and our sensors are the only ones that are classed as an IoT device, not the actual PC or your gateway. So you can see these are annual compound growth forecasts, really big on the Wi-Fi and Bluetooth. So that's growing it in industry because it's really flexible. But the home automation market's really kicked in. How many of you have come across Home Assistant? How many of you have come across ESP Home? It's really good, really simple to use. Great. What you find is there's a great background, community supporting people. So here we've listed Node-RED, which was developed by IBM. It's free to use. It's very good. Uses the MQTT protocol, which is lightweight, secure, UDP messaging, and then we've got something called ESP Home. So these are what's driving the home market, and you'll see some examples here of YouTube presenters actually showing a basic guide to how to create a sensor. So it's really good if we can have a product that can do Bluetooth and Wi-Fi all together. So we need some tools to compile for this. How many use Arduino, the standard Arduino library? Okay, very good on library support. My friend in the second row down there said, Dean, don't use Arduino. You need to use Visual Studio Code with Platform IO. I'm giving you the same advice now. Use Visual Studio Code with Platform IO. It's a much better compiler. You've got full hardware debugging in there. It's cross-platform, so it's got about 20 platforms. 13,000 libraries cover that platform support. And it also supports about 1,500 evaluation boards. So it's really well supported. One of the main advantages with it is the Arduino library management side of it. So in Arduino, how many of you have created a project, updated the library, and then recompiled and it doesn't work? At least one. I'm definitely one. With Visual Studio Code and Platform IO, you keep the libraries to that project so it doesn't interfere. So it's a much better environment, more professional. The advantage as well, if you don't like Arduino, because a lot of people say, oh, it's Arduino, it's not professional, you can use the IDF framework behind it, particularly for our Athosi or Stefano range. So I mentioned earlier Athosi. How many have used the expressive ESP32? Very popular. I mean, during COVID, it was one of the few processors that we could get hold of easily, cheaply. So Wurth wanted to go into that market, and we wanted to produce something similar, but we had to bring something else to it. So we've produced a 13.8mm by 9.8mm version of the ESP32. So it's running on a RISC-V5 processor. It operates Bluetooth and Wi-Fi. The Bluetooth's 5.0 low energy. It gives you 15 GPIO pins. The advantage is you've got I2C, SPI, I2S, which is typically used in audio, ADCs, and general purpose IO. So it's really good UARTs. It's got built-in antenna on the actual chip, so there's no external antenna. This might change in future. My colleagues in Germany say no, but my early evaluation board does have an external antenna on it. So I think if a lot of you guys ask for it, we would do it. So it might be possible. It's ideally suited for battery applications because its sleep current's only 1 microamp. So what I did is I got one of our evaluation boards here, and you can see that it's got 2 USB connectors. The top one is for when it's in Stefano mode. It gives the power to the board and allows us to talk to the UART and issues standard commands. Normally, as a Wurth FAE, I'd always stand in front of you and say it's much better to buy the One We Are Pro Wurth firmware in it. It's generally better. This is the only occasion where I would say buy a Athosi and put your own firmware in it. It's so simple, it's so well supported. It really is easy. So to program it, we use the bottom USB connector, and we use the top one just for power. So unfortunately, you do have to connect 2 USB leads to this one at the moment. But that's one side fault, downfall of it at the moment. So here you can see I've identified the analog pins that I'm going to use in an example later on, and some I2C pins. So we'll come back to a couple of examples later on. Another part of a sensor IoT devices, you need some sensors. So how many of you used Adafruit feather wings or any description? Quite a few of you. So typically they do M0s, SAM processors, Atmel chips. There's a great support for these feather wings. There's some really obscure ones. So I think there's one called the Cricket, which is a round one. It's the only one that doesn't conform to this footprint standard. But they're designed for easy use, especially in the Arduino environment. So it's more geared for rapid prototyping. So here Wurth's produced all our sensors in a feather wing. So on here we've got temperature and humidity, an absolute temperature, absolute pressure, and a 3-axis accelerometer. We also have a connector on there so it can interface to spark from Quicks or our differential air pressure sensors. So it's really quite good, and we offer this support for this part individually in STM32. So if you don't want to use an ESP32, you want to use a different processor, there is a library there to help you using an STM32. So we've got our evaluation board, and then we've got a feather wing. We need some libraries. So I'm talking purely from an Arduino background. I'm not a software guy, so this is coming from my experience and how I did sensors. So I'd use Arduino. You'd include your standard Wi-Fi library, which is supported in Arduino and IDF environment. A web server, because I want to publish a web page. And the wires used for the I2C commands. This is important because the pins that we're currently using on Stefano's tied up for another application. And I use the include wire to move the I2C pins to pins 3 and 10 for SDA and SCL. We mentioned that we want to publish to the cloud, so we need an MQTT library, and here we're using PubSub, MQT PubSub, which is not done by Wurth, it's done by a third party, but works with our Stefano or a Thosi. We did produce a library, which is the WeSend library, which covers the feather wing. That was based on the SAM21 processor, and that had timeout and I2C. So if you download this library and using it with a different microprocessor, you're probably going to hit an error. So here, I say you have to remove line 43. If I've got my glasses on, I can't quite see. So there is a line you need to remove that timeout in the library. However, on the examples that I'll share with you later on, all of that's been done for you. So the code will work directly on an ESP32, whether or not it's our ESP32 or an expressive ESP32. So I go back to this Visual Studio Code, and I could run through the code, and most of you will be better at it than me. So I'm not going to do that. Just to explain that I've created these examples, and I've created the libraries, and I've well commented them. So they're really easy for you to use. And maybe you want to alter it. Has any of you tried using Chatbot GPT to alter your code? No? Yeah? So I don't know how to use HTML. I used to get Jamie, my colleague at the front, to do that for me. But this time I thought, I've created a sensor, I'm publishing it to the cloud. I really want to create a web page. I'm not quite sure how to do it. So what I did is I got my code, pasted it into Chatbot GPT, and said, create me a HTML web page. I want it to have a table in the middle. I want it to have a reset button, and I want it to change color if the sensor falls below a certain value. Chatbot GPT created that code, and it worked first time. One other interesting feature in Visual Studio Code is there's an application called Genie, which my friend Jamie mentioned again. And that's automatically integrates this into AI, so it automatically comments your code. Because Jamie knew that this wasn't my code because there was comments in it. How many of you put comments in it and expect, 6 months later you come back and you can't remember how to do something? So even if you just use it for comments, it's really good to use, the AI intelligence to do that for you. So, done plenty of code. It's all done in Visual Studio Code, but there's no reason why you can't take Visual Studio Code and put it into Arduino. It's just a little bit more restrictive in what you can do, where Arduino's more forgiving. So if you've never done something and starting from absolute scratch, Arduino might be the first step, but sooner or later you need to step up a little bit and go to a more professional compiler, and Visual Studio gives you that flexibility without costing anything. It's open source and free. So it runs through the code, the bit boring stuff. So here's what I created. So I created this little demo. So it's using our Thosi board on the evaluation, and some of you might have actually seen this running on the stand. So what I wanted to do is create a web page with 2 analog to digital converters. You can see it's 12-bit, so it goes up to 4096. And then I wanted a PWM output. So there's a PWM slide bar at the bottom and some digital switching. I also wanted to fetch in the system time and alter the graphics. So this is based on, again, code that I found on YouTube, and credits given to the guy that wrote this code initially. But I wanted to alter it to meet my needs. I wanted to add MQTT to it, and I wanted to alter the color scheme, and I wanted to alter the pins and what it did. So it's really easy to do this. And as you can see from this example, it's quite responsive. The top one will flicker a little bit when I start touching the pins, simply because the pins are just floating, and I wanted to see how fast it could respond. So that's just demonstrating it, how fast I'm sampling. So typically on this one, I'm doing a 100 millisecond interval and sampling, but it can go faster and updating the web page. Mentioned then MQTT. Has anyone come across MQT Explorer? It's great. It's a nice little tool. If you've got a broker running, sometimes it's difficult to know how your messages are being published or if they actually are being published. So here, you just plug in your MQTT broker details and password, and it can log all your sensors. So the example that I've shown before with the analog to digital converters, you see the bottom 2 lines, it says analog A0 and analog A1. That's my messages coming into MQTT without setting up a full broker and writing the full Node-RED application behind it. So this is really good. And here I'm just demonstrating it. So one other things it can actually do is log temperatures or pressure. So here I'm demonstrating how I've got a chart to come in. So you can actually capture this information real time with very minimal overheads. So it's quite easy. Again, it's free software that I found on the internet, and highly recommend it. Has anyone come across canvas gauges? Yeah, looks really professional. So here, what I did is I wanted to incorporate canvas gauges in our sensors. So what I did is got my basic code, went on to canvasgauge.com, download their little instruction library, added it to it, wired up a Stefano with a temperature humidity, again from Wurth, and basically wanted to publish this command. So I wanted it to look more professional than the standard web page, having the gauges and the customizable gauges. So I think if anyone's seen the nice gauges that are running on the Home Assistant over on the stand, you'll see that the choice is yours. It opens up, it looks so much more professional. So here, I've actually got a little temperature sensor running. It should go up and down, I think, or if it clicks on. I think this is an older slide version, so my apologies. I don't think they've updated it. So here we're basically showing how simple it is. Now, one example that I have been demonstrating on the stand, and it's not part of this slideshow, unfortunately, so I'm going to have to refer to it, is we've got a Bluetooth module and a Wi-Fi module. Wouldn't it be great to be able to demonstrate that working both together on such a small module? So what I did is I went to Amazon and I bought some tire pressure sensors for my car, and they operate on Bluetooth. Now the advantage with these is they're advertising in what we call beacon mode. So they're just advertising their serial number plus the data. So by fetching that data in on Stefano or Athelia, I was able to parse that data and extract the tire pressure, the temperature of the tires position, the air pressure, and display it. So I was publishing that to Node Red. It works really well. But I also wanted to create its own AP, so it created its own web page. Again, I went back to Chatbot GPT, not knowing how to do HTML. Please create me this web page, and it works flawlessly. So this device, being really small, it's extremely powerful. The advantages are that if you're making a wearable IoT device, it's battery operated, so it's really good. One thing I would say is maybe some of you have used the LoRa network. How many have used LoRa? So the problem with LoRa, it creates a web page, it creates its own network, its own mesh network, but you need to get that to the cloud. So by adding an ESP, you can publish to the cloud. So it really ties in well. Plus, you've got the ESPs that can control the actual module itself. So again, there's endless possibilities how to do this. So MQTT Node Red is what I mentioned before, Home Assistant. I'm not quite sure how many of you have come across Home Assistant. It is really good. It is, I wouldn't say professional grade, but what I would say, it offers your guys that are developing something before you go into Azure or AWS environment. It gives you the ability to make your sensor, test it, really tie down and data log it. So it is a really good environment for you to test. So to get this up and running, a simple Raspberry Pi, the software's free. I highly recommend you do this and have a play with it. It will give you a great experience on how the devices are working, if there's any dropouts. One of the limiting factors of Wi-Fi is if you get a dropout, will it reconnect? You can answer this by using Home Assistant. It can actually monitor your devices to see if they actually drop off the network. So it's a great debugging tool for you. So I have I can share all my slides. It does have links to the code, what I've mentioned. It's a little bit shorter, this presentation, but if there's, normally we have an question and answer session. It's a little bit difficult with headphones on, so I will be staying around here or on the stand if anyone wants to come and talk to me more in depth. Hopefully that's just gave you a brief overview of how to create something really simple. We are going into too much detail. I've plenty of examples I can share with you, and it's on the GitHub repository. So thanks very much.